Alright, 6th graders, we are doing one of my favorite things today, and that is evaluating algebraic expressions. This is lesson 4, session 3. We are on page 75, and evaluating is another word. Be sure you write this down, don't forget it. Evaluating is another word for solving them. We're going to solve our algebraic expressions today. Here's our try it. A county fair has different ticket prices for adults and children. The expression 6A plus 5C represents the total cost in dollars for A, adults, and C, children. So the 6 is how much an adult ticket costs, and the A is how many adult tickets they bought. The 5 is how much the children's tickets cost, and the C is how many children they brought. So the Patel family here, they're going to spend, they've got, let's say we've got $6 for how many adults, plus $5 for how many children, and the Patel family's total amount they're going to spend is $38. So we're going to have to figure out here how many adult tickets and child tickets do they buy. And because there's two variables here, adults and children, we're going to kind of have to do a guess and check here. So if you want to try to figure out this out on your own, I highly recommend it. Go ahead and pause and do so now. Okay, now I'm going to show you how I'm going to do it. And what I'm going to do is I'm going to make a table that shows different possible amounts. So I've got the tickets, and then I've got my adults, and then I've got my, well, this is the number of tickets, so this is cost of adults, and this is the cost of the children. So if I buy one ticket for an adult, that's $6. For a child, it's $5. If I buy 2 tickets for adults, that would be $12. For children, that would be $10. If I buy 3 tickets, that would be $18 for adults, and that would be $15 for children. If I buy 4 tickets, if I buy 4 adult tickets, that would be 4 times 6 is 24. If I buy 4 children's tickets, 4 times 5 is 20. If I buy 5 tickets and they're all adults, that would be $30. If I buy 5 tickets and they're all children, that would be $25. So I've just thrown out a whole bunch of numbers here, and since I know I'm going to spend $38, I'm just going to see if I can find 2 numbers in here that their sum, if I add them, is 38. Let's see. Look at this right here, 20 and 18. If I add those together, I will have spent $38. So they bought 3 adult tickets and 4 children's tickets. I want to be sure I write that down so that I have my answer clearly in there, so I can, if I go and look back at my answers, I'll know what I actually did. So that is 3 adult tickets equals $18. 4 children's tickets is $20. Oh, why did I write 0? I need a 2 there. There we go. Okay. And then add those together. $38. There you go. Now let's look at how the book did it. Oh, look at that. Analyze it. So analyze it, you're just thinking about it. That's basically, mental math. You can use the terms and coefficients of an expression to give you information about the situation. The term 6A represents the cost of tickets for A adults, and the term 5C represents the cost for the tickets of $5 for children. The coefficients of the terms tell you how much each type of ticket costs. Where do you figure that out? For goodness sakes. Okay, now modeling it out, you can evaluate an algebraic expression by substituting the values for the variables. You can guess and check different combinations of tickets. Try to find a combination that gives you a total. So they just guessed. The first time they're like, okay, let's try 2 and 3. Well, 6 times 2 is 12. 5 times 3 is 15. That gave me 27. We need more than that. 27 is less than 38, so we need to try a greater value for one of the variables. So this time they tried 5. 6 times 5 is 30. And 5 times 3 is 15. And that gave them 45. That's too much. So their guess and check method didn't work out so well for them. Maybe they should have tried the table method like we did. Okay, let's see what they want us to do about it now. For page 77, number 1, look at the algebraic expression and analyze it. How do you know that the coefficient of the term 6a represents the cost of an adult ticket? So remember, the coefficient is the number, that's what the variable. So how do you know that that 6 represents the cost of an adult ticket? And that is because, let's keep this simple, because A is the number of adults. So if we're multiplying it by 6, that must be the cost of each adult ticket. Number 2, how does the order of operations help you interpret the expression 6a plus 5c and model it? Describe the order in which you perform the operations shown in the model. So remember, order of operations. Please excuse my dear Aunt Sally. So in this expression, now parentheses, it means when it says parentheses, it means do the operation inside the parentheses. There's no operation inside the parentheses, it's just a number. So that's not doing an operation inside. These two numbers are touching the parentheses. So this is actually multiplication. That's the operation that's happening there. So there is no operations inside of parentheses. There are no exponents. There is multiplication. There's no division, but you remember, multiplication, division, they're cousins. They're inverse operations. They go together. So when we write PEMDAS, we keep multiplication, division, and addition and subtraction. They stick together. It's not multiplication, then division. It's not addition, then subtraction. It's multiplication, division, then addition, subtraction. So it says describe the order in which you perform the operations shown here. So we're going to do the multiplication first. Do multiplication first. Then the addition. Okay, number 3. The choice for the variables in Model It do not give a total cost of $38. Dun dun dun, their Model It failed. Show the value of 6a plus 5c is 38 when a equals 3 and c equals 4. What does this mean about the number of adult tickets and child tickets for the Patel family flight? So basically it's telling you, it wants you to plug in 3 for A and 4 for C and write out how you would solve that. So we're going to do 6, but instead of A, we're putting 3. And that means, when we write it like that, that means multiply. And then we're going to put 5, but instead of C, we're putting 4. And we're going to see, does that equal 38? Well, I think we already figured that out, didn't we? 6 times 3 is 18, plus 5 times 4 is 20, and that does indeed equal 38. And the question it's asking is, what does this mean about the number of adult tickets and child tickets the Patel family buys? The Patel family buys 3 adult tickets and 4 child tickets. There we go. Number 4, how is evaluating an algebraic expression similar to evaluating a numerical expression? So when it says numerical, it means there's no variables, it's just numbers. And well, let's see, how is it the same? Well, you still use PEMDAS, right? We still use order of operations, but I'm just going to write PEMDAS. I'm going to change it to a comma, but it's different because a numerical expression will always be the same. But variables can have different values. Which we went over yesterday. Those ones had different values more often than these ones. Okay, and the reflection is for you to do. Think about all the things we went over and describe how one thing we went over so far helped you better understand how to evaluate algebraic expressions. Pause and do that now. Okay, you unpaused. You must have done it. So we are on page 78. We're going to do 3 practice problems together, and then your green pages are on your own. Number 6. A hot air balloon is rising. The expression 120 plus 2t, 2t's represents the height of the hot air balloon in meters after t seconds. So we don't know how many seconds. That's our unknown. Use the expression to find the height of the balloon after 15 seconds. Okay. So now it's giving us the seconds. So we just need to put the seconds in where the unknown was. So 120 plus 2, and instead of t, it told us to put 15. Okay, so remember, we have to do the multiplication before we do the addition. 2 times 15 is 30. We're going to bring down what we haven't used yet, and 120 plus 30 is 150. And that's meters, right? 150 meters. There we go. And we should put that on the line too, so I can grade it easily when I grade your papers. Even though you're not turning this page in, are you? So never mind. What is the value of the expression 4 times x minus y plus 2 if x is 7 and y is 1? So let's rewrite that with the new substitutions. Now x, we're going to change over to 7 because it told us to. And y, we're changing to 1 because it told us to. Plus 2. Okay, now we're into order of operations again. Please excuse my dear. Remember, my dear goes together. And Sally goes together. Okay, so we need to do what's in the parentheses first. So 7 minus 1 comes first. So I'm going to keep my 4 the same. And I'm going to do 7 minus 1 is 6. That's the first step, because that's the parentheses. Parentheses are done. There's no exponents. Now I do multiplication division. There's one multiplication step in here, because remember, when the numbers are touching the parentheses like that, that means they're multiplying. 4 times 6 is 24. I'm going to keep bringing down the stuff I'm not using yet. So now I've done all the multiplication division in there. Now I'm doing any addition and subtraction, and then there's just addition left, right? 24 plus 2 is 26. And that is A. Hurrah! Okie dokie. Whoop. That's not the scroll. Okay, last one together. You can use the expression 2L, and notice they do the cursive L so it doesn't look like a 1, plus 2W to find the perimeter of a rectangle where L is the length and W is the width. Use the expression to find the perimeter of the rectangle. So if you recall, just to make sure you know, remember, perimeter is the distance around the outside. It is the fence of the yard. So that's why we're doing 2 times each, because there's this side is 2/3 yard times 2 for this side. And then this side is 1/6 of a yard times 2 to get this side. Okay, so use the expression to find the perimeter. So we need to plug this stuff in. We've got 2 of the length, 1, 2, the length is 2/3, plus 2, 1, 2 of the width, and the width is 1/6. Okay, so we have to do our multiplication first. 2 times 2/3. Just as a refresher, we'll do it over in the corner. 2 times 2/3. All you do is, remember, to make a whole number into a fraction, put a 1 under it. Now it's a fraction. Ta-da. 2 times 2 is 4. 1 times 3 is 3. So this is 4/3 plus 2 times 1/6. Put a 1 under it. 2 times 1 is 2. 1 times 6 is 6. Plus 2, 6. Now, I'll pause here because look, we've got different denominators. But this is addition. To add fractions, you must have a like denominator. So I'm going to make them both into a 6. This one's already a 6. This one I have to multiply 2 to make it a 6. And if I multiply that by 2, I must multiply the numerator by 2 as well. So now it is 4 times 2 is 8. 3 times 2 is 6. Plus 2 6. That one stayed the same. So now I have a like denominator. I can add my fractions. 8 plus 2 is 10. And when we are adding fractions, we do not change the denominator. This is a final answer. It's not a proper final answer. So if you got this far, I'll accept it, but we really should make it proper. So you can either convert the improper fraction into a mixed number and then reduce, or you can reduce and then turn it into an improper fraction. I prefer to reduce first because I see they're both even numbers, which means they can both be easily divided by 2. And that's going to be 5/3. And this is a division problem, so I've got, oh goodness, I'm running out of room. I'm going to move this over here. I've got 5 divided by 3. That's what that is. 5 divided by 3 is 5 divided by 3. 3 goes into 5 one time. 1 times 3, though, is only 3. So my remainder is 2. The remainder is my numerator, and my denominator stays the same. So the perimeter is 1 2/3 yards. And I'm going to super circle it so I can see my answer later because I circled way too many things. What's the matter with me? Okay, and that is it for our work together. Go ahead and do your green pages, and good luck.